Educational GMAT. Your partner in your GMAT journey.
All right, guys, let's start. Yes. So I'll give you guys 2 to 3 minutes to understand this. Guys, are you done reading the question statement at least? So in this entire write-up, tell me which one do you think is the most important statement?
There is a perfectly linear relationship.
Absolutely. There is a perfectly linear relationship between distance and average speed. Perfectly linear relationship. What does it mean? What it means is that let's say if this is the distance and this is the average speed, correct? So basically what we are saying is that the relationship is this. It's a straight line between what and what? Between 3 meters and 15 meters. So which means what is it telling you, by the way? That as the distance increases, the average speed increases, right? This is very clear, right? Notice while hopping, notice as the distance increases, average speed increases. Distance increases, average speed increases. Distance increases, average speed increases. So that's a linear relationship. By the way, it's a linear relationship. This is the most important point. All right. Notice it clearly says between distance and average speed. So between distance and average speed, there is a linear relationship. All right. Now it says for each of the following predictions, select yes if given the student's assumption the data in the table, which is this, provide sufficient support for the prediction. And this is the first prediction. The average speed for hopping 3 meters, all right, would be greater than that. What is that, by the way? Average speed, correct. Than the average speed for speed walking 3 meters. So average speed for hopping 3 meters is greater than the average speed for speed walking 3 meters. Can we conclude for sure? Sorry? Yes, guys. How, I mean, I'll give you guys a couple of minutes. Think about it. How do we approach this? Average speed for hopping 3 meters. Hopping 3 meters. Mind you, we are given the data obviously only for let's say 5 meters, correct? And 10 meters, right? This is the data that we've been given for each of the 4 gates. Now, but then the clue is that there is a perfectly linear relationship, right? So average speed for hopping 3 meters. Tell me the average speed for hopping 3 meters would it be greater than 2 or lesser than 2 minutes per second? Lesser than 2, correct? Because for 5 meters it is 2, and so which means for 3 meters it will be lesser. Similarly, for speed walking, obviously it will be lesser than 2.4, correct? What's the exact value? How do we find out the exact value of average speed? How do we find out the average speed for speed walking 3 meters, right? That's my question. Now, here is the thing, right? Since the relationship is linear, what we can do is again find out the slope. What will the slope indicate, by the way? The increase in average speed per meter. Correct? Increase in average speed per meter. How much is the increase in average speed per meter for speed walking? Increase in average speed per meter. How much is the increase? How do you find this out? Notice for 5 meter increase, right? From 5 to 10, correct? For 5 meter increase, what is the increase in average speed? 2.6 minus 2.4, correct? So for 5 meter increase, the increase in average speed is 0.2 meters per second. So now unitary method, right? So for 1 meter increase, what is the increase in average speed? 0.2 by 5, right? Which would be 0.04 meters per second. Agreed? So which means if a person is speed walking, then her her increase in average speed is 0.04 meters per second. Friends, are we clear? Right? So now actually this is in fact something that you can quickly calculate actually for all of them if you want to, but that's okay. So now for speed walking, the average increase is 0.04 meters per second. So now can you tell me what is the average speed for speed walking 3 meters? 3 meters. Notice for 5 meters it is 2.4, correct? Right? No, so you're almost there, calculation mistake, Web.
2
So,
point
yeah, go ahead, Pradyum.
2.32.
Very nice. So, note, very nice. So, so you took point 0.4. So, I knew that. So, 2.4 is for 5 meters, right? For 3 meters, obviously, it will be minus 2. Why 2, by the way? By the way, 5 minus 3, right? Minus 2 into 0.04. Because it's 0.04 meter increase per 1 meter distance, right? So now we are talking about for 3 meters. So then it would be essentially 2.32 meters per second. Agreed? Now notice hopping 3 meters and speed walking. Now notice speed walking 3 meters is 2.32 meters per second. Correct? Hopping 3 meters will be lesser than 2. Notice because hopping 5 meters is 2. So hopping 3 meters obviously will be lesser than 2. Right. So we need to calculate. If we have the data, once we figure out slope, we might as well just write here. No, 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 no. It says that the data in the table provides sufficient support for this prediction. Which means, is this yes or no? This is not greater, right? So average is the average speed for hopping greater than that for speed walking? So no, that's the reason for no. Can this be predicted, right? That's the question. No, no, this prediction is wrong, that this average speed is greater than this. All right, let's read this. Uh, if given the student's assumption, and these are the assumptions, all right, the data in the table provides sufficient support. Does this data support this prediction? No, it does not support this prediction. This prediction is wrong. Clear, Sanjeev? All right. Okay, now come to this. The average speed for speed walking 15 meters, speed walking 15 meters would be greater than average speed for hopping 15 meters. For hopping 15 meters. All right. Again, same thing. Can you tell me speed walking 15 meters? Tell me again, since there's a linear relationship, what is the increase in average speed per meter of speed walking? So again, same thing, 2.6 minus 2.4 upon 5, right? That is for speed walking. And for hopping, how much is it? 3.1 minus 2 upon 5, correct? That's the increase in average speed per meter. This is for hopping. And this is the average increase in speed walking per meter. So this is how much, guys? 0.2 upon 5, which is 0.04. Am I correct? Right? While this is 1.1 upon 5, which is how much? God, 1.1 upon 5. 0.22. All right. 0.22 meters per second is the average increase for 1 meter increase in hopping. Correct? All right. Now I think we can find out easily for 15 meters, right? Because we have to figure out for 15 meters. 15 meters, what will be the average speed for speed walking? 2.6, right?
2.8.
Very nice. Plus 5 into 0.04, correct? Which would be 2.8. For hopping, how much will this be? 3.1, right? Is for 10, and we have to find out for 15. So which means plus 5 into 0.22. Correct? So how much is this? 4.2. So the average speed for speed walking is how much? 2.8 for 15 meters. For hopping, it is 4.2. So clearly 2.8 is not greater than 4.2. So the answer here would be no. Friends, are we clear? Everyone? All right. Now let's come to the third one. The average speed for speed walking backwards, all right, speed walking backwards for 15 meters would be greater than for walking forward 3 meters. All right. Walking forward 3 meters obviously will be lesser than 1.6. Agreed? See, because even for 5 meters, it is 1.6. So lesser than 3 meters would be lesser than 1.6. All right. Speed, average speed for walking backwards 15 meter. Walking backward 15 meter, tell me, lesser than 1.6 or greater than 1.6? Obviously greater than 1.6, because for 10 it is 1.6. So for 15 it will be greater than 1.6. So now here we don't even need to do the actual calculation, right? So clearly this is greater than this. Anand, Maria, Pradyun, Naina, everyone clear? Dipya?
Yes.
All right. So I think, yeah, this was really, again, in some senses, it draws upon the concepts of slope that we have been discussing in the past few classes. Yeah. So again, I'll reiterate because I'm getting a feeling some of you are not understanding this. So if this is distance, right, and this is average speed, correct? So what this basically statement says is that the relationship between these two variables is like this, guys. All right. So which means what? What, by the way, the slope, right, for this line, what does the slope indicate? Slope for any line is delta y by delta x. In this case, what would the slope indicate? Change, sorry. Yeah. Average speed, the increase in average speed for every 1 meter, right? Distance is in meter, right? So increase in average speed for every 1 meter. This is what the slope will indicate, delta y by delta x. Correct. So now let's actually, for example, look at this hopping, right? If you look at just these two, what would be delta y? Delta y, right? Notice y is average speed, right? So delta y would be 3.1 minus 2, that is delta y. What is delta x? It would be delta, notice x is distance, so that would be 10 minus 5. So whatever this calculation is, so 1.1 upon 5, which is 0.22. So basically what this says is, so this 0.22 is what? For hopping gait, this 0.22 is essentially the slope of this line. And what does slope of this line indicate in this case? Increase in average speed, right? Increase in average speed, which is delta y, for every 1 meter of distance increase. So now that you know, notice we are given this for 5 meters. We are also given for 10 meters. So obviously we can use this to find out the average speed at any distance between 3 meters and 15 meters. Notice it clearly says that this linear relationship holds true only for distances between 3 and 15 meters.